one of our research labs up in just north of Toronto in Canada. So right behind me here, I'll stand off to the side, is the NexION 5000. That's pretty clear to everyone. So this is our newest ICP-MS. What makes this great is a multitude of reasons, and I'll go through some of the systems as we're going. And also, you might notice that there's some nice annotations as I'm going along here too, and that's thanks to my colleague Trisha. It's going to help to make this a little more entertaining as we go through as well. So without further ado, let's start talking about the NexION ICP-MS. So the NexION 5000, the main features here and the main reasons why we think this is an important launch is not only is it a multi-quadrupole system, and I'll get into what those multi-quadrupoles are, but it's also designed to be very easy to use, very low maintenance. You know, a lot of people are apprehensive about getting to such a high level of technology on their ICP-MS. But we really think that we've come up with a solution that makes it quite easy for users. So not only is it easy to use, low maintenance, but there's a lot of nice standard features built in. I mean, there's on the side here, we can see all of our gas ports are on the side. We can push the instrument pretty much right against the wall. We've got 4 gas channels standard on the instruments. So that's very handy when you want to make use of all the reaction gases to really get your interference removal to the optimum point. Really, that is the point when you're using such a sensitive instrument. But let's start by going over some of the subsystems here. So the first thing I want to do is, we'll follow the path of your sample through the system. And so the first contact with the system that your sample will have is probably an auto sampler. But beyond that, then you're going to have some sort of sample probe going up into, I'm going to flip my camera here. So going in here. Whoop. So now there's our sample intro system here. So we've got our, a normal nebulizer. We got a spray chamber. The spray chamber can have an auxiliary port, have a argon dilution or oxygen addition if you're working with organics. You can even have a second line of both oxygen addition and argon dilution going at the same time if you'd like. With this system here, we've got a standard, a mini peristaltic pump. We've got a switching valve system with vacuum load assist, but you don't have to have that. That's just sort of optional things. And we work with lots of vendors. So there's all kinds of front-end connections that you can put on this. Anything that you can put on some of our lower models, NexION 1000, 2000, you can put onto the front end of the NexION 5000 as well. But what really makes this easy compared to a lot of systems is really, as I was mentioning, how easy it is to use. So to take your spray chamber off, you can just pull on it, basically. It's just a push fitting. You can just let that sit there. It'll just dangle by the nebulizer gas line. And I'm going to show you how easy this is. We're just going to remove the torch. Here's the torch mount, one-handed. And I'm not left-handed, but I'm doing it left-handed. So trust me, it's not that hard. So there is your torch and your torch mount. All right, so as you can see, there's the size of my hand next to the torch mount, quite compact. The torch itself, you can get one-piece torches with the injector built in, or you can have demountable injectors. It's just a single locking nut here on the back to remove those. So that's just the first stage of what's going on here. The next part, I'm going to open up so we can see the interface. So there's some nice buttons on the front here. One button to light the plasma. Right now you can see we've got a little orange LED. We've got reddish orange lights going here and here on the system. So we've got lots of colorful LEDs to tell you what the status of the system is. Let's go ahead and press this button here. We're going to open up, see the interface region. Again, more colorful LEDs, more things opening up. But what you'll see is the front door, the front panel of the instrument is going to open up. And we're going to get easy access to our interface area. So if we need to clean our cones, make any changes there, it's quite easy to get at. And also this helps you to show off some of the internal components you might be interested in. So there we go. The system's open. We've got some nice LED lighting on the inside. So we can see now there's our interface region right here. So here is our first cone, the sampler cone. Behind that, we have 3 cones actually. So we have the first cone is going to be your sampler cone. The second cone is going to be your hyper skimmer, like on any other ICP-MS system. But then we have a third cone, a hyper skimmer cone. And behind that, we have something called an Omni Ring. And I'll show you those parts and what those are for too. But just before I get to that, so your torch would come through here. Sorry, my camera keeps slipping there. But inside here, you can see this is the Omni Ring, we call, or not the Omni Ring, sorry, it's the Lumi coil. So many acronyms. Lumi coil, and that is what we're using as our RF coil now. So this is a fully warranted, non-consumable item. It's not actively cooled, it's passively cooled. So there's no air or liquid moving through that coil. There's just some cooling fins on it. So that will allow you to keep it cool without having any kind of additional chillers. And as I mentioned, that is not a consumable item. So you don't have to be changing that all the time, unlike older copper coils. The other thing you notice is there's no barrier, there's no shield between the RF coil and the cone system. All right, so there's no secondary discharge between them. It's a balanced charge on that. So again, very nice on that. With the cones, I'll just show you the cones as they are separately. So we've got, as I mentioned, the sampler cone. On these systems, they're all platinum tip cones as standard for the NexION 5000. So there's your sampler cone, your skimmer cone. You can see the peaks getting sharper and sharper. And then there is the hyper skimmer cone. And on the back end of that is the Omni Ring. So the Omni Ring is attached to the back, and that's part of how we run our ion guide modes. Okay, so we have ion guide modes. We do focusing or extraction mode, depending on what type of material you're running and what kind of sensitivity you're looking for. But that helps us to really either accelerate that ion stream in there or make it more focused so we get the best background equivalent concentrations. So those are just the internal points, and that's really the end of where you would have to do maintenance as a user. Beyond that, because we're using something called a quadrupole ion deflector, here's just a mock-up of that right there. This is, a mock-up, but this is the actual size. And really, this is where our first quadrupole system comes into place. So just before I sort of get into some animations, here's the rest of the system there. You can't really see much. There's just a giant vacuum chamber there. That's where all the magic happens. That's where we have some of our other quadrupoles. And that's how we're actually going to do all of our analysis right in that vacuum area. So let's go ahead and close up this interface. And while that's closing up, I'm going to press this button. I'm going to ask for my colleague Trisha to help me out here with a couple of animations. And we're going to talk about, some of the subsystems here. So we already talked about the torch. So the torch is the first section here. If you look at this hockey stick, we've got on the tip of that hockey stick, the torch section there. We talked about the Lumi coil, which is our RF coil. And we talked about the triple cone interface. So as Trisha was just pointing out, there's the the torch that she's going to annotate for me now. So again, depending on your application, we have multiple different torches you could put in there, whether it's organics, high purities, those kind of things. But what I really want to get into and what you can't see is what Trisha is adding in now. Here's our quadrupole 0. So the cones are just a little bit below that section there. That's it there. So that's what she's pointing into now. That's our quadrupole 0. And that's why I was just pointing out. Quadrupole 0 is what we would call our quadrupole ion deflector. So quadrupole ion deflector is really there to bend the ion stream 90 degrees. All right, so all of our photons, all of our neutrals are going out, past the vacuum area so we can get a really low signal, and we're not allowing any of that to get back into the system to keep that background low. So that's part of the beauty of our system. Between the triple cone interface and that quadrupole ion deflector, the Q0, we're keeping our background as low as possible, and you don't really need any maintenance past this point. So that's really a nice feature for this system. So moving on, past quadrupole 0, as I mentioned, this is a multi-quadrupole system, so we're going to get into multiple quadrupoles. The first main filtering quadrupole is Q1. So it's that big long section right after the quadrupole ion deflector, Q0. And so this is a focusing quadrupole. It has an AMU range from 2 to 285 AMU, and it's got a mass resolution. Typically we're running at about 0.7 AMU, but we can focus it down to 0.3 AMU mass resolution. And that's the same whether we're working with Q1, Q3, which we'll get to in a bit, or working with them in combination. So this really helps us to look at a very fine resolution and even quantify half masses if we would like to. So the next step after Q1, and so if we're filtering with this step, this really helps to, set what's getting into the next stage of our analysis or our next stage of our quantification, which would be Q2. And that is our universal cell. So Q2 is another quadrupole. There is a quadrupole in our reaction cell. And this is where we're going to inject any of the reaction or collision gases. So being a true quadrupole allows us to have bandpass filtering. So we can actually help to reject more actively any kind of side reactions that we're not trying to create. So it's a really nice system in that regard, better than having an octapole or a hexapole because of that bandpass filtering ability. So beyond that universal cell, and I guess one more point there, we do have those 4 gas channels I was pointing out before. Not only can you have the pure gases moving in there, but you can have combinations of gas flows from those different lines to create a custom mix. So sometimes not a single reaction gas is effective. Sometimes you can get an even more effective reaction if you mix some of those gases online. So that's a really handy feature of having these multiple gas lines into a single cell. So next step here, and the final quadrupole in our system of our multi-quadrupole ICP-MS is Q3. And Q3 is pretty much exactly the same as Q1. Q3, again, is going to give us a true filtering quadrupole, same mass resolution. We can go down to 0.3 AMU, so very fine. Typically, we're running at 0.7 AMU. But basically, both of those main filtering quadrupoles are better than 1 AMU resolution. So you can be confident in the signal that you're getting. And so we can work in tandem with Q1 and Q3 in MS-MS mode. We can use just Q1 to be our main filtering quadrupole, and then Q3 as an ion guide, or you can reverse it, and you can have all of these different combinations. So really useful tool to have, and really nice to have these multiple quadrupoles. So just that's the big technical overview. But after that, I'd just like to point out a couple of quick things in the software. So I'm going to take back over. Thank you very much, Trisha, for those annotations. And here we go. So now, just going to show you. There we go. So here is just a quick shot of what our software looks like. So it's very visual based now. You can see you've got our main ICP-MS, but all the subsystems are separate if any issues occur. So right now I have the torch out, so it's giving me a red coloring for the injector. and it's going to give me a warning telling me that, yeah, I've got something missing out there. So if I were to click on this subsystem, right away, it'll show me that there is a caution, and it means that there's an interlock problem, the torch mount position. So that is true. I have the torch out, so it's reading that correctly. But really simple, really intuitive software. It's just a main toolbar at the top with all the sub-programs you might be needing to do. So Smart Tune to optimize your system. You've got advanced optimize for some of the more advanced tunings, mass calibration, your conditions file. So all the parameters that you're going to do or use for operating the system. And those are all basically optimized for you in the Smart Tune system. In your methods, so we've got our method screen here. We've got a helpful periodic table on the side. When you select a different element, it will tell you what available isotopes there are, what their natural abundance and potential interferences are. So helpful information there. And then when you're building out your method, you can add in your elements as you go, choosing your ion guide mode, choosing whether you want to have quadrupole 1 or quadrupole 3 or both active. You know, you can choose which kind of gas mode you're going to be using. So all, you know, just from drop-down menus, very simple to implement, very easy to use. And then just a nice thing when you see your results, here's your results screen there, the reporter. You can click on your individual calibrations. It'll show you a blown up view of your calibration. So it gives you values there. So just, you know, pretty nice layout there, pretty intuitive. So that's just the quick overview. Obviously, I could spend quite a long time talking about this system, but it is quite a nice thing. And I would just like to open it now. If you have any specific questions, I'd love to take a couple of questions and answer anything you've got going.
Hi, I can definitely be the one who orchestrates the questions. So one of the first questions we have here that I believe Trisha will be animating for us as well. Will the charge on the Omni Ring increase the frequency of maintenance and cleaning?
So there is a charge on the Omni Ring, and with any charged surface, it can attract more material. But again, the Omni Ring is part of the cone system, essentially. So very easy to access, and you'd just be cleaning that when you need to along with the cones. You never have to break the vacuum to clean those, so you're never having much downtime when you do this. And it's, again, relatively simple. It is connected to the hyper skimmer cone, so the same cleaning procedure as we would normally have the hyper skimmer combined with that.
And then I have another question here. Do the voltages have to be optimized? Do you keep the voltages the same in a method, or can you change them and use a different QID optimization?
Yeah, so there are custom QID optimizations, quadrupole ion deflector optimizations. So you can set up 2 more custom QIDs. We also have a built-in custom QID just for cold plasmas too. So you can optimize your system however you would like, and you can call those up based on your ion guide modes. So you can choose which you would like to do. And that all is built into the method there. So when I was showing you, there's the focusing and the extraction mode. There's also the cold plasma mode, and then custom modes as well. So you can create a custom setting for whatever you find is best for your personal materials that you're analyzing.
Excellent. And then we have another question. What types of matrices represent or present major problems or cannot be run? So what types of...
Okay. That's a good question. Yeah, there are obviously some issues with different matrices, but there's usually a solution depending on what you're looking at. So, you know, obviously challenging ones might be things high in total dissolved solids. You know, typically ICP-MS, they like to run with fairly low total dissolved solid concentration. However, you can do things like argon humidification, specialized nebulizers that can handle total dissolved solids or higher total dissolved solids. And you can do argon dilution in line. So the argon dilution happens on the neck of the spray chamber, and we can dilute your signal before it even gets to the plasma, before it gets to your injector. So all these things combined could help that way. Organics, again, no problem. We're going to just use some oxygen addition to burn off the carbon. But generally, we've run quite a few things on this, from concentrated acids for semiconductor industry, some solvents, bloods, urines, so biological materials. All these things can be run on the ICP-MS, so the NexION 5000.
Does anyone have any other questions? You can type them in the chat if you desire to. Okay, I think we're all set on the Q&A portion.
All right. Well, thank you everyone for joining me today on this quick demo of the NexION 5000 multi-quadrupole ICP-MS. I appreciate your time, and thank you very much, and have a great day.
Wait, sorry, Andrew, really quickly. Apparently, we have another quick question.
Sure.
Do you recommend cold plasma for this? I'm sorry.
So cold plasma is really effective when you've got argon interferences on some of the lighter masses. So this is really going to be a nice technique, especially, you're looking at calcium, iron, these kind of things where there's big argon interferences. Cold plasma can really help, especially because, those elements that I mentioned before, they're easily ionizable. So going to a cooler plasma, you still have enough ionization efficiency to get a great signal without having as much of a problem with the argon interferences.
And can you run this in the same method?
Yeah, you can. So that's the other nice thing. We don't need to create a second method. As I was showing in the method editor there, we would just change individually for different masses, different isotopes, which ion guide mode we want. And then the instrument itself will just switch to whatever ion guide mode you're needing for that specific isotope that you're looking at. So you can go from cold plasma on calcium 40 to a DRC mode for titanium maybe, or for chromium, and then you can go back to cold plasma for iron 56 if you want, and it will group them and run them all together in their different modes, and you have no problems. And so all in one method, you can have multiple ion guide modes, multiple quadrupole modes, and it's not an issue.
And what is the typical runtime for that, Andrew?
So with any ICP-MS technique, it's additive. So the more isotopes you're running, the longer your method will be, right? So we can't do a simultaneous method. It is sequential by mass. But typically, you're going from a short method with a few elements or isotopes. It'll be, under a minute. And once you're getting to more complex methods where you've got, 60, 70 isotopes you want to read back on, you're going with different gas modes, all of that will add up, and maybe you're looking at maybe 4 minutes with that. And of course, depending on your sample introduction system. So if you have a fast introduction system or something with a switching valve, you can cut down on the loading time for your sample and save you both on your loading time for the sample and of the rinse out. So again, it depends on your system, depends on your needs, but definitely when you're talking to someone about it, let them know what you're analyzing and what your expectations are, and we can usually find a customized build out for you.
And then we have another question right here. Is it preferred to use a multi-element standard solution of higher number of elements in total quaints for accurate results?
That's up to you. So you can have multiple calibration standards. I think we allow for up to 40 calibration standards. if you wanted to break them out or you want to have just a few in each standard. It also depends on chemical compatibility, right? So depending on the elements in your solution and what your acids or solvents are in there, there might be some chemical incompatibilities. Like, for example, if you got silver in your solution, you don't really want to have nitric acid. That's going to make it fall out of solution. So, or sorry, hydrochloric acid, because that's going to make silver chloride. So it'll fall out of solution quickly. You just want nitric acid. So that's something to be aware of. But as long as they're all compatible, you can have all of your elements all in the same solution when you're doing a total quantification.
Thank you. I'm just waiting for a few other questions to come in. We still have a few minutes left if anyone has anything else. Okay, Andrew, I think you're good to go.
All right. Well, thank you again to everyone, and thank you for your questions and for your time today.